This video will be about segments. So we already described in the basic vocabulary video what a segment is. So the purpose of this video is to explore some of the properties of segments, how to calculate their lengths. And that's where we'll start. So let's say we have this one-dimensional number line here. And we want to calculate the distance between this point and, say, this point. So we'll label this point A, we'll label this point B, and someone says find the length of segment AB. What might you do? Well, you could literally count off the distance because these 2 points aren't that far away from each other, and you might count it off and say they have a length of 5. Okay. But what if B was located all the way at 1,000? It wouldn't be worth our time to count off from -2 to 1,000, right? That would take too much time. So is there an arithmetic shortcut to finding the distance between 2 points? And you may already be aware that all you have to do is find the difference between the two. So we could do point B's location minus point A's location, which would be 3 minus a -2, and we get the same answer of 5. But what if we accidentally did A minus B, and we did -2 minus 3, and we get -5? Well, lengths have positive values. Okay, we want a positive output from our calculation. So to avoid making the mistake of outputting a negative value, to find the length between any 2 points, no matter where they're located, so the length of a segment, that will be equal to the absolute value of one endpoint minus the other. So, or you could do A minus B, and we can say where A, we'll do capital, A and B are the endpoints of the segment. Now, this formula is strictly limited to objects that are one-dimensional. Once we enter a two-dimensional plane, the way we calculate the length between two segments is going to encompass a few more steps. Now, if we're working along a horizontal line or a vertical line, we'll actually be fortunate enough to still utilize this. But once we get to a 2D plane and look at how to calculate distances, we'll see where our definition is going to differ a little bit. So this is a formula for distance between 2 points when we're on a one-dimensional object. Now, one of the postulates that you need to know for a segment is if we introduce point A, we'll do point B, we'll connect them with a segment. We're not going to label this. If I add a third point on this segment, so point C, there's a postulate. Oh, I don't want that. There's a postulate that arrives called the segment addition postulate. You're responsible for knowing this postulate. And it says that if A, B, and C are all on the segment together, where A and B serve as the endpoints, and C is between A and B, then we know by the segment addition postulate that AC plus CB must equal AB. And that should come as of no surprise. Like if I just take this portion and add it to this portion, I'm going to get the length of the entire segment. So using this segment addition postulate, we can find the lengths of subsegments if necessary, right? Like if I know the whole thing's 10 and I know this is 3, then I know AC is 7, things like that, okay? So we can utilize this basic idea, it's not too complicated, right? Where it says basically the sum of the parts equals the whole. So that is the segment addition postulate. Now, what if we come across a segment that has a point that is exactly halfway in between the endpoints? to the point where AC and BC are of equal length. So we could say something like AB is equal to AC plus BC by the segment addition postulate. And in this scenario, we would know that AC and BC are congruent. What you're going to see notationally, or even in the picture, you'll see these little tick marks, okay? And when we see a tick mark, that indicates that the length of the segment is equal to the length of the segment with the same amount of tick marks, okay? So if I introduced another line that would be equivalent to AB, I could say this entire AB, and I can put 2 tick marks, okay? So the number of tick marks tells you which pieces are congruent to each other or equal in length. And that introduces the next point, understanding the difference between equality and congruency. So equality refers to being equal in numeric value. So when we refer to the length of this is equal to the length of this, the measure of this is equal to the measure of something else. When we're dealing with congruency, we're talking about equality between geometric objects. So we're no longer talking about length. We might say segment AB is congruent to segment DF or something along those lines. So in the case of this segment that we have here, we could say segment AC is congruent to segment BC based off of the fact that they give us these 2 tick marks. And that would be a geometric equivalence. I'm saying this segment and this segment are congruent. And if I know something's congruent, then I can say the length of AC must be equal to the length of BC, because now I'm equating numeric values. Okay, so understanding the difference between equality and congruency we'll get more work with, but just know congruency is referring to the actual geometric object, and when we see an equal sign, we're talking about an actual numeric value. So we've established this point C is right in the middle of A and B. So the next maybe logical question would be, is there a special name for C? And when we have a point that is exactly halfway between 2 other points, we would refer to as C is the midpoint. Of segment AB. Okay, so point C is the midpoint of segment AB. And the midpoint, by definition, bisects the segment. Okay, and bisection means cut in half. So you're going to hear those terms a lot. Angle bisector, segment bisector. That's referring to something that's cutting it in half. The midpoint is exactly halfway between 2 points. Okay, so if this whole thing was of length 4, then we know that this is 2 and this is 2. And if this was at location 0, then this is at location 2 on the line, and so on and so forth. So there's a bunch of things we can take away from revealing a midpoint. But make sure you understand what a midpoint is, and make sure you understand what the term bisection means. Cut in half. And speaking of bisection, to end the video, you should be aware of what a segment bisector is. And that's just referring to a ray, segment, or line that intersects the segment at its midpoint. So we can introduce a line that passes right through this segment. So that line that passes through, this line BC, we would say something like BC, because we need 2 points to describe a line, is the segment bisector to AB. And you can see it passes right through its midpoint, so we know that it cuts this thing right in half. And that is the conclusion to the introduction to segments.